Everything in the universe follows rules. Gravity, curvature, expansion, from galaxies drifting apart to clusters forming giant webs. It all follows a pattern, or at least it should. But the more we study the universe, the stranger it gets. Because the shape of the universe, the thing that defines how everything moves, refuses to make sense. We expect a universe with a clear geometry. Something curved, something bent, something shaped by all the matter inside it. Instead, we found something almost impossible. A universe so perfectly balanced it shouldn't exist. Not by chance, not by accident, not even with the laws of physics we know. And here is the weird part. This shape isn't just about how space looks. It decides how the universe began, how it grows, and how it ends. Yet every measurement we take points to the same disturbing truth. The universe is acting as if it's flatter, smoother, and more precise than anything in nature should be able to create. Something is off. Something is missing. And the deeper we look, the more the universe bends the rules we thought were unbreakable. When scientists talk about the shape of the universe, they are not imagining a giant ball or a giant bubble floating in space. They mean the geometry of space itself, the way distances stretch, the way light travels, the way gravity bends everything around us. Space can curve, it can bend, it can wrap around itself, and depending on that curvature, the universe can be one of three things. It can be closed like a surface of a sphere, where if you travel far enough, you end up back where you started. It can be open, endless, expanding forever, shaped like a giant saddle. Or it can be flat, perfectly balanced, stretching out in every direction with no curve at all. These shapes decide everything. How galaxies move, how the Big Bang unfolded, how the universe will end. And here is the catch. We should be able to measure the shape easily. Look at the light from the early universe, see how it bends, and boom, there is your answer. But when we measure it, the numbers come back too perfect, too clean, too flat. Flat in a way that almost feels engineered or forced by something we don't understand. And that's where the real mystery begins. If the universe was slightly curved, that would make sense. A little bend here, a little stretch there, random, natural, and messy. Just like everything else in the cosmos. But that's not what we see. Our universe looks perfectly flat. Not almost flat, not close enough. Perfectly flat within a margin so tight it should be impossible. And that is the problem. Because for the universe to be this flat today, it had to start even flatter in the beginning. So flat that if the density of the universe at the Big Bang had been off by even the tiniest amount, everything would have collapsed instantly. Or blown apart so fast that nothing would ever form. A universe this balanced is like flipping a coin and getting heads 1 trillion times in a row. It shouldn't happen. Not naturally and not randomly. Scientists call this the flatness puzzle, and here is why it keeps them awake at night. In a universe filled with matter, and dark energy, the shape should drift over time. Gravity pulls, expansion stretches, the balance changes. But our universe doesn't drift, it stays flat. Perfectly steady, as if something is correcting it. As if the universe is locked into a state that refuses to tilt in any direction. It's like walking into a room and seeing a pencil standing perfectly upright on its tip, not moving and not falling, just balanced in a way that should not be possible in nature. So the question becomes unavoidable. Is that a coincidence, or is there something about the universe we don't understand yet? If the universe is this flat by design, then the rules we use to explain reality might be incomplete. The universe is not sitting still. It's stretching. Every second, space grows a little larger, pushing galaxies further apart. You can think of it like a slow, steady breath that never ends. Now, here is the strange part. As the universe expands, its shape should drift. A flat universe should become curved. A curved universe should flatten out or curve even more. Gravity and expansion are always fighting, always changing the balance. Our universe doesn't behave that way. We measure galaxies billions of light years apart and their distances follow a pattern that doesn't shift. The shape stays the same. It's like the universe is expanding without changing the geometry underneath it. That shouldn't happen. Not in a natural system. Not in a universe that is supposed to be chaotic and full of moving parts. Imagine stretching a sheet of rubber. Pull it enough and the shape changes. It curves, it bends, and it reacts to force. But the universe does something else. It stretches and somehow stays perfectly even, perfectly smooth, and perfectly balanced. That means one of two things. Either the universe began with the most precise conditions possible, a setup so perfect it feels unnatural, or something is controlling the expansion in a way we do not understand. Dark energy plays a role, but even that doesn't explain the stability. Dark energy should create small differences, small bends and small ripples, but the universe keeps expanding as if it's following a blueprint, a rule we have not discovered. A rule that locks the shape into place no matter how big the universe becomes. And that brings us to an even stranger problem. A problem that pushes this mystery into the impossible. As you know, there is a limit to how far we can see. Not because our telescopes are weak, but because light takes time to travel. The universe has only been around for a certain number of years, so we can only see as far as light has had time to reach us. That limit is called the cosmic horizon. Everything inside it is the observable universe. Everything beyond it is invisible. Not because it doesn't exist, but because its light has not arrived yet. Now here is the problem. When we look across the sky, we see regions of space that are impossibly far apart. Light from one side of the cosmos could never reach the other. They have never touched, never exchanged heat, never communicated in any way. Yet they look the same. The same temperature, the same smoothness, the same structure, as if they matched their properties long before the universe even began to expand. That should be impossible. Imagine two people on opposite sides of the planet. They never meet, they never talk, they never share a room, yet they somehow paint the same picture using the same colors with the same brushstrokes at the same time. That is what we are seeing in the sky. Different regions of space that could never have interacted are perfectly synchronized, perfectly coordinated, behaving as if they once shared information and then suddenly moved apart faster than the speed of light. This is called the horizon problem, and it means that either our understanding of the early universe is wrong or the universe did something unthinkable in the beginning. Because for these distant regions to match so perfectly, the universe must have been connected in a way that breaks the rules of physics. It behaves like a puzzle that has been assembled before we were allowed to see the pieces. And to explain that, cosmologists came up with a solution, a really bold one, and a solution that created more problems than it fixed. To explain the horizon problem, scientists proposed the idea that sounded simple at first. The universe expanded. But before that expansion slowed down into the gentle growth we see today, there was a moment when it exploded outward at a speed that makes the speed of light look slow. This moment is called cosmic inflation. A tiny fraction of a second after the universe began, space expanded faster than physics should allow. Not once, not gradually, in an instant. And for a while it worked. Inflation explained why distant regions looked the same. They were once close together, they were once connected. And then inflation pulled them apart faster than light could follow. It also explained why the universe looks flat. Stretch anything fast enough and curve disappears. It becomes smooth, even and balanced. Inflation was the miracle answer, the quick fix for a broken universe. But as we look deeper, the problems returned. First, we have never found the cause of inflation. What force triggered it? What energy drove it? What stopped it? It behaves like a cosmic engine that turned on by itself and shut off by itself, with no mechanism we can identify. Second, inflation does not predict a universe this smooth. It should have left behind tiny differences, tiny scars, tiny distortions in space. Some of those distortions exist, but others are missing. The universe is smoother than inflation says it should be. And then comes the strangest part. Inflation might not have happened once. Some models say it could happen again and again, each burst creating another universe, another bubble, another pocket of reality expanding in its own direction. If that's true, our universe is just one bubble in a larger sea of universes. A multiverse, a place where inflation never really ends. Inflation was supposed to explain everything. Instead, it opened the door to something even stranger. A universe that might not be alone, and a shape that might not be confined to the space we see. If the universe was simple, the story would end here. But every time we look deeper, the universe throws something new at us. Something that does not fit. Something that hints at a shape far stranger than anything our models predicted. The first clue comes from the oldest light in existence, the cosmic microwave background. A faint glow left over from the beginning of time. It should be random, chaotic, scattered evenly across the sky. But it's not. There are patterns in that ancient light. Subtle alignments, large-scale structures that stretch across enormous distances. Scientists call one of them the axis of evil, a strange direction in the universe where temperature differences line up in a way they shouldn't. It looks like the universe has a preferred direction, a cosmic north and south, something a random universe should never have. Then there is the cold spot, a region of the sky that is far colder than everything around it. Too large, too empty, too perfect. There is no clear explanation for it. Some say it's a statistical fluke, others think it's the fingerprint of something beyond our universe, a bruise left by a collision with another bubble of space. Even the distribution of galaxies reveals something odd. We see walls of galaxies, voids the size of entire clusters, structures so massive they should not exist in a universe this young. They stretch across billions of light years as if space is following a hidden blueprint. All of this points to a universe that is not random, not symmetrical, not shaped only by matter inside it. It hints at something larger, something deeper, something built into the fabric of space itself. Every new observation adds another piece to a puzzle that shouldn't exist. A puzzle that suggests the universe has a shape we have not discovered. A shape that may stretch far beyond the parts we can see. At this point, the universe starts to look less like a simple expanding space and more like something crafted with rules we do not fully understand. Every clue we uncover points to the same unsettling idea. The shape of our universe may not be the whole story. It may only be the part we can see. And that opens the door to possibilities that sound impossible at first until you realize they explain the data we cannot ignore. One idea says the universe is curved, but not in a way we can detect from the inside. The same way a fish cannot tell if the ocean is curved. We might be inside a space that bends through a higher dimension. A shape we cannot visualize because we are trapped inside it. Another idea says we live in a bubble universe, a pocket of space born from inflation. If so, there could be other bubbles floating in a larger cosmic sea. They might collide, they might leave scars. That cold spot in the sky might be one of them. There is also the holographic idea. The suggestion that everything we see, everything we touch, everything we think is real might be a projection from a boundary outside of our universe. Space, matter, energy, all encoded on a distant surface we can never reach. And then there is the possibility that the universe is not curved or flat in a way we think at all. That our measurements are only showing us a shadow of a deeper geometry. A geometry shaped by forces we do not yet understand. It would mean the universe is not broken. It would mean that our models are. All these ideas point to the same conclusion. The universe is not as simple as we hoped, not as predictable as our equations pretend, not as straightforward as the textbooks say. It leaves us with one final question. If the universe refuses to follow our rules, then what rules is it following? For all of our telescopes, equations, and theories, we are still staring at a universe that refuses to reveal its true shape. We measure one thing and it leads to another question. We solve one mystery and it opens a door to something even stranger. Every step forward feels like peeling back another layer of reality, only to find a deeper one underneath. The universe is flat when it shouldn't be, smooth when it should be chaotic, aligned in ways that defy chance, filled with structures too large for its age, and shaped by forces we still cannot identify. So what are we really living inside? A bubble in a larger multiverse? A curved space hidden inside a higher dimension? A hologram projected from the edge of reality? Or something we haven't imagined yet? What we know is simple. Our universe is not behaving like a random accident. It's behaving like something with rules we have not discovered, patterns we have not detected, geometry we have not mapped. And that leaves us with one final thought. If the universe refuses to match our expectations, maybe the problem isn't the universe. Maybe the problem is our understanding of reality itself. So I will ask you this. If the universe has a deeper shape, a hidden structure, a design beneath the surface, what do you think it really is? Thank you for watching. Keep looking up.